case, all right. So thanks for coming. My name is Joe Marini. I'm a principal PM at Microsoft on Windows Phone. I focus basically on the web developer platform, so that means IE9. And I actually brought it today. This is my Mango phone right here. I'll be showing IE9 on my phone later. So let's go ahead and get started. But first, somebody in this session is going to walk out of here with a phone. Not a Mango phone, because those, yeah, I know. A few more months about, but I'll find some way to give this thing away. I don't know. I'll find some way that will cause the least amount of controversy. So let's quickly go over what I'm going to talk about today. So first, I'll talk about just overall, review of how the mobile web has changed and where we are today. Describe ways that the mobile web is kind of different from the desktop, some things you have to understand when you're building mobile websites. And then we'll go into some specific guidelines around things like building websites that work really well in the mobile context. Then I'll talk a little bit about IE9 specifically, about how we approach building it, the kinds of things that we learned, and then I'll take some questions if we have time left. So the mobile web has actually come a long way very quickly. How many people remember this? Yeah? How about this? You remember that? Yeah. So from there to what we have today, that's quite the amount of progress. Just, not even 4 or 5 short years ago, that far left graphic, that was the mobile web, right? You had 160 by 160 in all of its glory with a monochrome screen and WML and all that great stuff. But the mobile browser has come a long way since then. And because of that, because of the strides that the mobile browsers have made, it shouldn't come as any surprise that the browser is actually the #1 application in terms of total user face time on the device, and is responsible for more than half of all the data traffic that goes through a typical phone. Okay? No, it's not Angry Frickin' Birds. No, it's the browser is #1. And I have links to all these studies in the deck, so when you get the deck, you can look it up yourself. But this was a study done by a company called Zocam, and you can see who's on the high right side over there. It's the device web browser, right? And that graph, it's a little bit of an eye chart, but basically it says the x-axis is what percentage of monthly users use that application, and then the y-axis is what's the average monthly face time using it, right? So you can see that not a lot of people use Twitter, but when they use it, they spend a lot of time in it. But look at the browser, right? The browser, almost everybody uses it. Something like 90-something% of the people use it, and they spend a lot of time in it. And as a result, right, the browser results in half the data traffic goes through the browser. So the browser is here and now. And in an ironic twist of fate, it's kind of funny. Because the mobile web is so relatively new, at least with modern phones, the browsers are actually a lot better than you'll find sometimes on the desktop, right? The IE6 problem doesn't exist on Windows Phone, for example, right? Or even, pretty soon IE7 will be gone as well. So for the most part, you have modern browsers across smartphones. And as a result, you can build some really advanced stuff. And by next couple of years, most phones will have the ability to do things that only native apps can do today. Now, to be clear, I want to make sure this graph is not, I'm not making any promises on Windows Phone here. This is just illustrative purposes. Like today, geolocation, pretty much everybody has that, right? But things like the accelerometer, things like camera, things like contacts access, all that stuff is coming. Like some phones are experimenting with that today, even though the spec's not done yet. But what's great about building web apps on phones is that they're really great for rapid iteration of design and content that's dependent on a subscription, right? Stuff like the Times or any kind of publishing content, or stuff where you have to change your content rapidly, like, say, e-commerce, for example, right? That really fits well into modern web app development as opposed to making a native application. There's a lot of advantages, and I'm sure you guys all know this. We've seen this happen on the desktop web, right? There's a lot of advantages in being able to do cross-platform coding and being able to take advantage of the simple distribution model that the web has. So with stuff like widespread use of CSS3, HTML5, modern scripting engines, like especially like the new Chakra engine in IE9 that have a lot of high performance, it's pretty. We're approaching the point now where you're going to be able to build apps that rival native apps in terms of performance and appearance. And by the way, if you have questions as we go along, please feel free to ask them. I know we have mics and stuff set up, but we're a small enough crowd where we can just have a conversation. So if you have questions, let me know. Other important thing to remember is mobile is a scenario. It's not a form factor. Like if you ask a lot of developers, like, well, what's different about mobile? They'll be like, oh, the screen is smaller. Well, yeah, I mean, the screen is smaller, but mobile is more than just about having a small screen. Like up until about a year or two ago, the largest screen on the typical smartphone was maybe 4 inches across, right? Well, a funny thing happened on the way to mobile screen sizes, right? This happened. I mean, if you think about what devices are mobile today, right? You've got Kindles, you've got Galaxy Tabs, you've got iPads. All these are mobile devices, right? I mean, people typically have these out and about with them. They get taken to bed with them. They're there in the morning. They take them shopping, right? They're all over the place. So it's not just the small screen. I mean, to be clear, yeah, the small screen matters and other physical characteristics matter, right? For example, on the desktop, you typically have a really full-size, nice keyboard. You usually have a hyper-accurate pointing device, like a mouse, like a tablet, like a telekinetic brain interface, whatever you've got that points really accurately, right? It's typically you have one of those on the desktop. You have typically a large screen, and usually and now these days more. How many people have multiple monitors on their PCs? Yeah, almost everybody, right? Yeah, it's very common these days to have more than one monitor. You've got a nice big honking CPU with a big GPU. Right? You compare that to the mobile device world, that's not typically the case, right? You've got no keyboard or a limited virtual one. You've got your finger as a pointing device. These are like, pretty big compared to styluses. The screen can rotate, so the content can change form because the user can do this, right? The CPU, yeah, they're pretty powerful, but not compared to desktops these days, right? They're still like a little generation behind. So those are important physical differences, but those lead more importantly to experience differences. And the experience differences are that typically when someone's using the web from a desktop device, they're in a fixed, persistent location. Even laptops are usually used from a stationary position, right? You don't normally walk around with your laptop out on the street, like, typing as you go, right? Phones, you do that all the time, right? So desktops tend to be good for things like open-ended browsing. It's really easy for the user to context switch among things like, I've got my spreadsheet over here, I've got my email over here, I've got my web browser over here, and while the spreadsheet is doing some formula calculation, I can read my email and do whatever else. Because the user can easily focus on a task and then change that focus as time and needs warrant, right? On mobile devices, that's typically not the case. Right? Usually, you've got your phone with you, and you're out and about somewhere. You're in the back of a taxi, and you're going through tunnels or shady and sunny areas, and it's not. You don't have a nice big screen, so it's not typical that the user will context switch among a lot of open applications for long periods of time. So phones really lend themselves to things like quick data consumption, right? You might like the term data snacking sometimes gets thrown around, where it's like I need to know the answer to a question, so I check my bank balance, right? I check directions, I see where I am, that kind of stuff. So the user tends to be focused more on tasks that are individual and discrete, and they're often an adjunct of what the user is already doing, right? So if I'm in a bar or a restaurant with my friends or whatever, and I'm using my phone, I'm not usually focused on that. Maybe I'm transferring money from savings to checking so I can pay the bar tab or whatever, but it's not the main focus of what I'm doing. It's an adjunct to what I'm already doing. So all of those things lead to differences in the way that we have to design websites. Because people have different expectations about what they're going to get from a mobile web experience versus a desktop one. Right? Mobile users are used to having immediate access, immediate answers to questions. They're used to being able to just get what they need. They expect that the information that they get is going to be augmented more and more by the real world, where they are, what time of day it is, right? Because modern phones can do that kind of thing. The fact that the environment can change unpredictably has a pretty profound effect on how you design web-based applications for mobile, right? The lighting might be dark and indoors or harsh and outdoors, and that affects things like readability. What the network speed is, what the background noise is, or even other things that are not necessarily physical, but like the relative surroundings of the user. If I'm on a crowded bus and I need to check if I need to log onto my bank account, I might think twice about that if I've got a bunch of people around me and the first thing my bank website does is dump me into my account details, right? So I might take that into account as a mobile web designer and developer and say, oh, well, maybe I should give the user a way to go to a screen that's not quite so sensitive when they first log in, right? So those kinds of things come into play when you have mobile design decisions to make. So what makes all this possible and what makes the world of mobile web development so rich is that phones today know a lot about where they are in their surroundings, right? I mean, this is one of the major differences between phones and desktops. Phones know what time it is, right? Because they've got a clock inside. They know where they are. They know whether it's dark or light outside. They know if they're moving around because they've got an accelerometer. They know what direction they're facing in, right? They can see and hear things because they've got microphones and cameras, right? There's all kinds of sensors that are built into phones these days that did not exist years and years ago. And now you might be saying, okay, fine. Now, as a web developer, I don't necessarily have all these available to me right now, right? Most people have clock and geolocation, but things like accelerometer, things like camera, those are coming, right? Those are now beginning to be developed and addressed by the W3C. So that kind of stuff, right, has a profound effect on how we develop mobile websites, right? There's a lot more you got to take into account as a mobile web developer than a traditional desktop guy might have to think about. So let's take a look at some development principles that this results in. So I'm going to go through these in the following sections, and then we'll see examples of stuff on IE9. I'll talk a little bit about IE9 a little bit. But in general, these are some of the more important design principles that you need to follow when developing mobile websites, right? First, design for one web, right? And I'll explain what each one of these means. So don't design for, there's no such thing as the mobile web, the desktop web. There's just a web, and just design for the web. There's things you can do to build pages that are just mobile friendly. They take advantage of things like fingers, and they understand that they're mobile. Building designs that are clean and succinct and easy to understand is important. The idea that you focus on core stuff that the user is trying to do is a really important part. You don't want to just simply take your entire existing site and try to shoehorn it into something this big, right? That's just simply not going to work. And then typically you have content that you've got to get from desktop onto mobile, right? So what does that mean? How do I adapt what I've already got onto my phone? And then I'll talk a little bit about progressive enhancement and testing. But to get into some details, all right, design for one web. So what does design for one web mean? Basically, it means that you should endeavor to try to make sure that when people go to your website, regardless of what phone that they're using, they can at least get access to the information that your site provides, right? Now, notice I did not say they should get the exact same graphic experience on whatever phone that they have, right? They should just be able to access the information. Just because I have phone X or phone Y, I should be able to go to my mobile banking site and find out what my balance is, right? I shouldn't get this message that you can't come in here because you don't have ultra-modern phone, whatever, right? So the way that you do that is by making sure that you've separated the content of your pages from things like behavior and presentation, right? So that means using semantic markup, right? Don't do things like embedding JavaScript and CSS directly in the page, directly in line with the markup, because that makes it a nightmare to have to port across, right? Separating out CSS and JavaScript, putting them in separate files, that kind of stuff, right? If you've already done that, then your job is much easier. But the idea is design for one web, right? Use each piece for what it's intended for. Use markup for meaning, use CSS for presentation, use JavaScript for behavior. Okay. So after that, after you've gone through and done that simple little exercise with all your existing pages, you can do things that make pages mobile friendly right from the beginning. So first, design for the finger, don't design for the stylus, right? Now, lots of styluses still out there, right? I come to praise stylus, not to bury him, right? Styluses are still relevant, right? But good finger-friendly design is also stylus-friendly, because styluses are pretty rigid, right? They're pretty accurate. But what you need to do is make sure that features aren't only accessible by pinpoint size styluses. Make sure that hit targets are big enough to tap easily, right? Fingers are typically 40 to 80 pixels in size, so you need to make sure that hit targets are big enough that people can tap on them. They're spaced wide enough that there's no competition between the hit targets, that kind of thing. On Windows Phone, in the Metro guidelines, we typically tell people don't make your hit targets smaller than 7 millimeters, because that's about the size of most fingertips. Mine tends to be towards the upper end of that range. And not only that, but fingers can do a lot more than styluses can, right? Fingers can flick, they can pinch, they can zoom, they can make little infinity symbols, they can do all kinds of cool things. So with all the new touch events that are becoming available in modern browsers, right, it's easier to take advantage of those kinds of gestures than if you simply design for the stylus. All right. When building pages, it helps if you optimize the layout for vertical scrolling. And the reason for that is because people, when they typically hold a phone in one hand, right, they can just easily, users are used to doing this. They can flick up and down with their thumb, and they're not used to necessarily panning to the left and right in web pages, right? They may not realize if you put content to the left or right that they might miss it. They might not realize that they can pan left or right. Content just simply naturally flows better when you have it optimized for the vertical layout. And in fact, it also works on non-touch screens as well, because if the user has something like a BlackBerry where they have that little trackpad or some navigation element on older web cable phones, they can use the arrow keys a lot more easily. But if you just make it vertical, they've only got one direction, one axis that they have to worry about. They don't have to realize, oh, there might be content to the left or content to the right. All right, so be crisp, be clean, be succinct, be gone, right? That's basically what this means. So pages that use fewer fonts and colors and point sizes and so on are much, much more readable. So remember, when someone's typically using a phone, they may be out and you don't know what the lighting is like, right? So if you go hog wild with things like colors and fonts and different point sizes and font faces, that makes it a lot harder for people to consume the information that's on the page. But beyond that, just avoid things like gratuitous graphics that don't have anything to do with the content. They're just there for decoration or unnecessary interactivity. You'll see this a lot on the desktop web, for example. Like if you go to a restaurant website, they got some big, long flash animation that intros you to the site and it sets the mood and whatever. Maybe you can tolerate that on a desktop site. But on a mobile phone, you're just irritating the person. You're keeping them from getting to the information. So try to avoid doing stuff like that. Things like background images are also necessary to avoid. Why? Because when background images get compressed down for the smaller screen size, they tend to get darker. All the pixels move together, and so they tend to darken. And you also get unpredictable moire patterns in the graphics, depending on what the image looks like. So that can make the page hard to read, especially if you have text overlaid on top of it, and the text is different colors that are competing with the pixels. That makes stuff hard to read. So avoid background images. And also don't forget that when you have images, speaking of images, to optimize them for the small screen context. If all you do in your web page is say width equals 320 by 320, and the image is actually really this big, you haven't actually saved any bandwidth. All you've done is told the browser that the display surface is smaller. You actually do need to go back and resample the image and actually make it smaller, right? One thing you need to be careful of is that some content delivery networks out there very helpfully try to do this for you if you haven't done it. So if you've done something like, if you're using CSS files and you've got CSS image sprites where you got a big image and then you use background positioning just to show icons or whatever, if that image is bigger than the screen, some delivery networks that are run around the world and here in North America as well will see that and they'll be like, oh, the image that's going to that phone is far larger than the screen is. Let me helpfully compress that right on down for you there. And then when the image gets to your phone and you're trying to position stuff, all the pixels are off. And so just be aware that don't try to avoid designing images that are larger than the physical screen size. All right, another important guideline: minimize required input when you can. The reason I say this is because entering data on a phone can be a real pain in the ass, right? It's like you can. Especially if you have a small keyboard or if you have a virtual keyboard or whatever, it can be a real tiresome task for the user to have to enter a lot of data. And anytime you require the user to put data into the phone manually, that's a break in there. That's a seam, right? There's a break in the user experience there. They have to stop what they're doing, right? They got to focus on the phone, right? They got to type stuff in. Now, obviously, people are used to putting data in phones. Right? People send billions of text messages every day. Right? They said emails from phones are probably almost more common than emails from desktops now. Right? So people can put data in phones. They're used to it. But again, the context is usually a little bit different. Like your friend might easily forgive you if you text them with misspelled words or numbers that are wrong. They might understand what you mean. right? In the case of building web forms for applications, that's not going to fly, right? You want to make sure that you don't want your bank to think you meant $2,000 when you really meant $200. So anytime you have to require the user to put input in, right, they've got to stop and focus on what they're doing. So what do you do? Well, first, only require the minimum amount of stuff to get the job done. Or if it's a big task, only require the minimum amount of stuff to make significant progress, right? So, I mean, if you take an example, like transferring money in a banking application, that really only requires 3 pieces of data, right? The source account, destination account, amount of money, right? The application can infer the rest. If they don't put in the date of the transfer, you can assume it's today, right? If they don't put in an entry for the memo field, whatever, just leave it blank. Okay, so minimum amount of data just to get the job done. But beyond that, you can also do things like provide sensible default values, right? Don't just assume, for example, that the user has never done anything before. Like you can save information in things like cookies or local storage, right? So if I've using my banking app and the last 3 transfers I made are $100, $200, and $300, rather than making me type that in, just give me a link, right? If I've got a movie site that shows me times for movies, don't show me movie time. Don't show me purchase links for times that have gone by already that day, right? Things like that. And then finally, look at alternate ways of getting data into the device. Things like the clock, things like geolocation. In fact, if you look, I don't know if I have it on this particular, so yeah, so, whoops. So this is an example. This is Fandango's website. So on the far left, when you first go there, they try to find out where you are, right? So they let you type in your zip code, or they progressively enhance their page and they say, oh, this device supports geolocation. Let me show this nice big tappable button that says, find where I am, right? So if you click that button, it figures out where you are. Then when you go to the next screen, it shows you what movies are in theaters. But again, they're making intelligent design decisions here. They're not showing it in alphabetical order or anything like that. They're showing it in the order that the movies are when they came out. They're from newest to oldest, right? Because chances are that's what most users are going to want to see the order in, right? They're going to want to see movies they haven't seen yet, so show me the newest stuff first. But what's really cool is that using the information that Fandango already has about the world around it, like where you are and the time of day, on the far right there, they've got this what's called a Go Now feature. So just by going to the Go Now tab, it'll say, okay, near you, here are the movies that are starting within the next 60 minutes, right? So without me having to type anything at all, I just simply fire up this web page, press a button, and I can find out movies near me within the next 60 minutes, right? So I don't have to type anything in because they're using an alternate way of getting data in, and then they remember this. The next time you come back, they'll say, oh, last time you were here, you came from this zip code. I'll just default to that. All right. So next important principle is focus. You must focus, my young grasshoppers. What does this mean? Focus on the core scenarios. The idea here is that good mobile web apps tend to focus on just the most important stuff. And you really need to resist that temptation to look at your existing site and say, how am I going to get all these features onto that phone? That's not the idea. The idea is figure out what people are really trying to do and then put those features on your site and make them prominent without the user having to scroll. Because remember, mobile users are typically mobile. They're on the go, right? They don't want to stop and figure out how to use your site, right? So if you can make your site understandable within just the blink of an eye, just a few seconds, right? Then the user gets their job done, they get on their way, right? They're just much more happy. Whoops. Let me show you an example of that. So here, let me bring up the other monitor over here, and I'll show you what I mean. So if we take a look at United's website, right? Yeah. So this is the website for United Airlines. Right, and obviously, there's a whole bunch of things you can do here. You can plan your vacation. You can check your Mileage Plus account. You can, research travel destinations. You can check in. You can get flight status. You get all these things, right? Well, if I'm mobile, chances are I'm most interested in this right here, check in and flight status, right? So if you look at the mobile version of their site, right, this is the mobile version. Look at the difference there, right? So first, all the stuff fits on one page. right? You don't have to scroll to see everything. Like that's pretty much all there is just right there. And the top two features are check-in, right, and flight status, because chances are that's what most people are going to want to do when they're in the back of the taxi heading to the airport. They want to check in, they want to see their flight's on time, right? Now, below that, there's other things you can do. You can look at my reservations, right? You can just see if things, check flight availability. You can do other stuff, but they're further down in the list. And then finally, down here, there's a link to the full site if I want to see the full site, right? If I've decided that I'm in this mode of using my phone where I'm comfortable on my couch and I want to see the full site, fine, I can do that. But they default to the mobile view, and they give you a focused set of scenarios right up front. All right. Let's go back. All right, any questions on any of that stuff so far? No? All right. So next is getting content onto your mobile device. Most people have existing websites, right? They have content that's already there, and there's a challenge of how do I get my existing content on my mobile. There's a few ways you can approach this problem. The first approach is don't do anything. Right? The do-nothing approach is just deliver your existing page to mobile devices. Most mobile browsers these days are rich enough where they can handle that. And in fact, this actually works well in some situations. It works well in situations like, for example, blogs. If you have traditional 2 or 3 column layout pages, this solution is not entirely bad because most mobile browsers these days, when you navigate to a site that's laid out using a 2 or a traditional column approach, when the user double taps on one of the columns, the browser senses the outermost block level element and then zooms into it, right? So they'll say, oh, you double tapped on a div, let me zoom that into view. So if you have content that's laid out vertically like that in columns, the do-nothing approach actually works. It's not optimal, right? But at least you're not hosed. You can get your content onto mobile pretty quickly. But beyond that, there's things like basic mobile adaptation. There's things that you can do to tell the browser, hey, here's how the page should be laid out when it's on a mobile device, and specifically when it's laid out on a mobile device that might have varying screen widths, right? From 240 to 320 to 480, so on and so forth. And the way you do this, there's a couple of meta tags that have been implemented over the years that inform the browser, hey, this is mobile content. Please don't try to optimize the layout, because some modern browsers will do that. They'll sense the desktop, they'll sense the page coming down, they'll look for these meta tags, they won't be there, and they'll say, oh, this must be a desktop page, unless the doc type is something like XHTML mobile, and then they'll say, oh, I know how to optimize this, I'll just do some layout tricks and it'll make the page better. So these tags turn that feature off, and they tell the browser, here's how you lay stuff out, and I'll show an example of that. Then there's multi-serving. Multi-serving basically means it's the same page, and it's going to 2 different devices, one's desktop, one's mobile, and you're basically using CSS media queries to shape the styles that you send down to each particular device. Media queries are part of the CSS specification. I believe their recommendation as of earlier last year. Almost every modern mobile browser supports them now. Ones that don't, there are ways to get around it. There are some polyfills out there that you can use. But the idea here is you've got one page, you style it appropriately, and it works on both formats. And then there's, at the other end of the spectrum, from do nothing, there's mobile-specific design. This is where you build your mobile site, right? You've got m.whatever, or you've got site.com/m, right? You're building pages that are specifically tuned and optimized to work on mobile screen sizes. This usually involves some form of browser detection, like user agent sniffing, something like that. The problem with this approach, well, it works pretty well. If you can, you can sniff the browser, you can redirect, and so on. The problem with this approach is that user agent sniffing is inherently backwards looking, and it's hard to get right, and it's hard to make future-proof. So I'll talk a little bit about ways you can address those problems, but those are some of the challenges there. All right, so let's take a look at some examples. Let me take a look really quickly at, yes, let's bring this one up right here. So I'm going to switch over to the code really quick, and I'm going to bring up a sample that shows how the viewport tab works. Actually, no, I'll do that in a minute. Let's move on to this first, and I'll bring that up. So specific mobile guidelines I want to talk about is these are specific technical things you can do when developing your web pages for mobile browsers. First, use well-defined standards. Well-defined standards, now of course these are important for web development anyway, but they're even more important on mobile. And as a minimum baseline, you can typically use things like XHTML 1.0, HTML4, XHTML mobile profile, CSS2. These are understood by almost all of the modern mobile browsers going back several years, even pre-iPhone. A lot of Nokia phones will understand this stuff, for example. If the device supports things like HTML5 or CSS3, then you can progressively enhance your pages and say, oh, this page understands video, this page understands audio, and then add those features, right? But the idea is design for the baseline first, and then progressively enhance later. Make sure you always specify a doc type for your pages, because doc types tell the browser what's about to happen. If you don't specify a doc type, then the browser will say, oh, this must be Quarks mode. And so make sure that you specify a doc type. Doc type HTML for HTML5, that usually works. As long as the doc type is there, that's what's important. If you're going to use media types, make sure you're using standard media types like GIFs, PNGs, JPEGs. If you're going to use dynamic media, 3GP is always good. Most phones progressively or download that stuff. Things like WMVs or MP4s. Most phones will understand one of those. Usually MP4, usually 3GP. And then finally, avoid stuff that is known to cause issues. And some examples are things like frame sets, right? So frame sets will work because the browser can lay them out on the mobile phone. The problem with frame sets, there's a couple of them. One, they take up a lot of space, right? Those borders on frames. When you've got pixels on mobile screens are very, very expensive, right? Because you've got very few of them. I mean, these are like the Manhattan of pixels, right? It's like every pixel has to be accounted for. They're very expensive. So if you've got a lot of pixels being devoted to things like frame borders, you're wasting a lot of space. That's one problem. The second problem is because frame content can scroll, and most phones, when you put the finger on the screen and you move around, that means pan the page, right? Typically, scrolling within a frame requires a separate gesture, and that's not very discoverable for most users because sometimes you use 2 fingers, sometimes you do something else. Some browsers just take the content of frames and expand them out so the user doesn't have to scroll. So just avoid things like frame sets. Tables also. Well, tables used for layout. Tables for tabular data, that's fine. That's why tables were invented. But using tables just to achieve layout positioning, that bloats the code really quickly. It makes it hard to adapt to multiple screen sizes. And nested tables make that problem even worse. So don't use tables to achieve layout. Of course, we shouldn't be doing that anyway. Things like image maps, again, they work, right? Image maps, they technically work. The problem with image maps is most image maps respond to what, right? Mouse over, right? So what happens is you hover over the image map, something on the image map lights up, and then you know to click on it. Well, there is no such thing as finger hover on a mobile device. The phone can't detect that somebody's finger is about to touch the screen, so there is no hover effect. And that's why actually hover effects on mobile devices are just a bad idea for any reason. And then things like plugins or DHTML behaviors. Most phones won't let users install things like plugins or ActiveX controls or behaviors or whatever. So don't show the user a page that says you need the latest version of Flash. Well, you can't get the latest version of Flash on this phone, so avoid stuff like that. All right, so let's talk a little bit about the mobile-ready pages. So if you've laid out a page specifically for mobile, you can tag it as such using some meta tags that say to the browser, hey, this is a mobile page. Don't mess with my layout. And there's three such meta tags. And these have been invented various times throughout history. So handheld friendly goes way, way back to the Avant Go browser days. And basically, it's just a true or false thing. It just says, hey, this page has been optimized for mobile. It's not used much anymore, obviously, but most search engines will see this and they'll say, oh, this is a mobile web page, and they can do that. They can use that information for whatever they want. The next one, mobile optimized, Microsoft invented that back in the Pocket PC days. And the value that goes in the content field there is the width of the screen. So if you say mobile optimized, say content equals 320, or you can say content equals, I think, -1 or something like that, which means whatever the screen width happens to be, right? The most recent one, however, is the third one there, and that's the viewport tag. The viewport tag has become something of a standard. Just about everybody supports it now. It was invented by Apple. They put that in the iPhone. And the viewport tag allows you to do things like not only control like how wide the content is on the screen, but you can do other things like determine whether or not the user can zoom in or zoom out, how much they can zoom in, zoom out, that kind of thing. And we support that on Windows Phone as well. And yeah, so the nice thing about the viewport, what it does is it decouples the size of the page from the size of the display window, right? On desktop browsers, the width of the page is whatever the width of the window happens to be. The problem with mobile devices is that the user can do things like zoom in and zoom out. So that's what the viewport does. The viewport says whatever the width of the page is, it doesn't necessarily have to be tied to the screen width. So you have to tell the browser, hey, I've laid this content out to be a certain width, like 320 or 480. Or if it's fluid, you can say things like, well, width is device width, right? And then the browser on the phone will say, okay, well, this screen is 480, so I'll just make the width of the document 480. There's different defaults based upon which phone you're using. If you don't specify a viewport, the browser will make an assumption about what the width of the page has to be. And most browsers assume a value somewhere around 1,000 pixels. Like on Windows Phone, we assume 1,000 pixels. iPhone assumes 980. Android assumes, I think, 900. Opera Mobile assumes 850, somewhere around there. So they'll assume a page width of around 1,000 pixels if you don't specify this. So, oh, whoops. So let me show you an example of using the. Let's see, an example of using the viewport, and I'll switch over to my. There it is, viewport underscore start. Oops, get back over here. Start, HTML, and let me bring it up. All right. Let's see. So let me bring it. Okay. So this web page right here has no viewport tag in it. In fact, let me bring the code up so you can see it. And that's this guy right here. So I've got my doc type, I've got my HTML, my head, and that's pretty much it. And here is the design down here. If I switch to design view, okay, this is the design of the page, right? So you've got my pictures, I've got my title, my H1, and so on. And you can see that when you lay this out on the mobile device with no viewport, that's not the layout that I was going for, right? Obviously, I'm looking for a result a little bit different than that. So if I go to the one where we've actually included the viewport, and I bring that guy up here, right? So now you can see that with the viewport tag, the content fills the screen correctly, right? The images look right, I can scroll, so on. Let me go back to the source so you can see that. So this is the same file, but all I've done is add these three tags right here. And most modern browsers will recognize all three of them, and they're smart enough to know which one is the most recent, right? So if you do this on Windows Phone will say, oh, the viewport's there, that's the most recent one, that's the one I should use. If it's not, if only Mobile Optimizer is there, I'll use that one instead. And most browsers are like that. So let me show you an example of how device width works. So let me bring up this guy right here. Viewport, and I believe it's size test. Yep. Okay. So what we're seeing is this document right here. I've got 5 divs. Each one is absolutely sized, starting at 240, going up to 1,000 pixels, right? Different colors. And so if I look at this on my phone, okay, you can see that when there's no viewport tag specified, Windows Phone defaults to 1,000 pixels, right? This would look different on an Android phone, and so on. So let me show you what happens when I rotate it. And I'll just put this in here, turn the keyboard off, and rotate, right? So when I rotate, it just gives me the same view. So what I want to have happen, though, is I want my content to be optimized for the right view width, and then when the user rotates the phone, because I've got more horizontal space, the document should adjust, right, to take that into account. So what I'm going to do is go back into the source, and I uncomment this meta tag right here. Now, in this case, I'm not using a hard-coded device width. What I'm doing is saying viewport equals whatever the device width happens to be. So let me go back to the emulator, and I'll unrotate this. Okay, and then I'll refresh it, right? All right, so in this case, now that the viewport tag is there and it's saying width equals device width, now it's defaulting to the value of 320. Now, Windows Phone actually has a screen width of 480, right? But when you use the device width keyword, it defaults to 320 instead of 480. And the reason we did that is because most mobile websites that were designed prior to Windows Phone's introduction were optimized for a certain other phone that's prevalent in the market right now. And that had a viewport width of 320 pixels, right? And we found that most websites, when they say, oh yes, I'm optimized for whatever the width of device width is, they're really not. What they did was they said, oh, well, device width is just 320. So I'll just make my width 320. And so a lot of websites broke. And so on Windows Phone, whenever you say device width, we assume you mean 320. But now watch what happens. When I rotate the phone, right, because the horizontal space changed, right, using width equals device width now gives me more horizontal space, and now you can see the 480 layer there as well, right? So we expanded the viewport out. All right, any questions on that? Yep, okay. All right, let's continue on then. Okay, so the next step up from there is multi-serving, and multi-serving basically means using media queries. How am I doing on time? I'm doing okay. So media queries were invented as a way to apply different style sheets based upon certain conditions of the browser that the content's being viewed in. The most common that are being used in mobile today are things like orientation or the display surface width or the device width. They're a candidate recommendation as of July of 2010. I put the URL in there so you can go read more about them. But the nuts and bolts of what you need to know is right down there on the bottom. The idea is you can use them either inside the CSS itself or you can use it in the link tag. If you say link, style sheet, and then you say media, now normally you'd say screen, right, or print or whatever. What media queries allow you to do is say screen and then you can put some conditions in there, like the maximum width of the screen is 800 pixels, right? That means apply this style sheet. Or screen and orientation is landscape or orientation is portrait. So that allows you to choose among style sheets. The most commonly used ones and the most commonly supported properties across browsers are things like height and width. You can also say things like device height and device width. So width means whatever the width of the window is, because that can change, right? Device width means the browser is going to ask the device, hey, what's the maximum width or height you can be? And then report that back to the style sheet mechanism, right? So there's an important difference there. And to make it even more confusing, you can use prefixes like min or max. So you can say things like, apply this style sheet when the minimum width is 400. So if the window gets larger than 400, right, that means apply this style sheet, right? If you say max, that means apply it when the size is up to that size. And you can use things like ranges. You can say min this and max that. So if you have like a style sheet setting for screens that are small, like phones, and then you can have another range for things that are tablets, right, between, like, say, 480 and 800 pixels, and then you can have a screen size of larger than that. Like, larger than 800 pixels, you can say, oh, that's probably a desktop. So those are the most commonly used one. And here's some examples. So, for example, to detect a device that has a maximum screen width, you would use the device width keyword. The example I just gave where you had a range, that's the second one there, where you're detecting a window that has between a minimum width and a maximum width. And again, you can do this in both the CSS file or the HTML code itself. So to actually see this in action and see what it does, let's just quickly switch over to an example. And that's right there. So this is on the IE test drive site. Nope, that's the wrong one. Oh, yeah, that's the right one. How many people have gone to the test drive site for IE? Yeah, OK. So if you go to the test drive site and you look under the HTML5 section, whoops, you'll see this example right here. So what I've got is a web page that's laid out with images and some text, right? And it's basic photo gallery stuff. So if I start to make the window smaller, like watch what happens. So as I scroll it down, you can see that the divs become a little bit smaller until we reach a size where the layout changes, right? So now the text that was below each one of the headings is gone, right? The images are a little bit smaller. And if I keep on going, then I get to a point where a media query is applied that just simply takes out all the text and aligns the images in vertical fashion, right? All this is accomplished using media queries. And the source code is available on the test drive. So if you just go to ie.microsoft.com/test drive, you can see this example and download it and play with it. Okay. So let's minimize that. All right. There are certain HTML5 technologies that lend themselves really well to helping build mobile applications. Geolocation is one of them. This is something that up until recently only native apps had access to, but pretty much every modern smartphone browser now has access to geolocation. Obviously, what it does is it lets the browser figure out where the phone is, and it does this using a variety of methods. Typically, it'll do things like look at IP addresses or wireless network. If it can't figure that out, it'll go off the cell towers. It'll just send out messages and then use the location of the cell towers to figure out where you are. Or if your device has GPS, then it'll try to use the GPS sensor. You can get location either one time, or you can do like if you've used JavaScript and you've used things like set timeout, you can actually continually watch the position as well. It works the same way as a timer does. And because of the obvious privacy implications of things like knowing where you are, the W3C requires that devices that implement this feature let the user opt in. So, for example, on Windows Phone, when we go to figure out what your location is, if a website wants to do that, you get a little notification that says, hey, this website wants to know where you are. Is that okay with you? And then you can say yes or no, and then you can choose to whitelist that site so that in the future you're not bombarded again with ongoing messages. The full W3C Geoloc API is available at that URL right there. This is one of the few W3 specifications that's actually easy to read. It's only a few pages. The API is actually pretty small. And I'll go through it here. The support for it is really good. I mean, pretty much just about every browser you're going to run into these days supports it. It's accessed off of the Navigator object. So the way you typically use this is you do a test, say, hey, if navigator.geoloc is not null, then I've got geolocation. And the API, this is pretty much the API right here. So the first three functions, the first is get current position. That's the one shot. That's just hey, tell me where I am. And the way that it works is you give it two functions. The first one is if everything went fine. The second one is if there was an error, and that's optional. And then there's the options object. And options let you specify things like whether you want high accuracy. Yeah. Yeah, that's a good question. So does this return long and lat, or does it give you more data than that? So geolocation, the W3 specification gives back long and lat. It comes back. Yeah, right. Yeah, it gives you long and lat, and then there's all kinds of third-party APIs out there. Like Bing Maps has an API where you can just say, hey, given this long and lat, where am I, right? You can do nearby searches, right? Things like that. So IE9 supports this. You can use Geoloc on IE9. The watch position function is the continuous watcher. So it works pretty much the same way as get current position, only it's like an interval timer, right? You simply say watch, and then it just keeps on watching. And then when your position moves appreciably, which the W3C leaves up to each browser vendor, but which typically means if you move more than, say, 10 meters, then the call will come through again and say, oh, yes, your position changed. Here's your new position. And then clear watch goes along with watch position because you can turn off the watching. So let's take a look at an example. Typically what you would do is something like this. You'd say, hey, give me the object, right? If it's not undefined, then I would get the current position, and I would define these two positions for success and failure. And whoops, go back. There we go. And this is pretty much all you need to do. Let me show you guys what it actually looks like on IE9. So let me bring up my, yep, there it is. Let me switch over to the Wolf Vision. Okay, there it is. Okay, can you guys see that okay? Once it stabilizes? Is that better? Yeah. All right. So what I'm going to do is just scroll down here, click on Locate Me, right? You can see that when I say locate me, hey, do you want to share your location? Yes, I do. So it's going to go out, and I'm live here, so hopefully this will work. And it's locating. The hamsters are running as fast as they can. And this may take a few seconds. Yep. Oh, do I have? Oh, don't have network access in here. Dang. All right. Well, anyway, that's the risk you take when you're working live. Yeah, we'll come back to other examples later. Anyway, so that's geolocation. Yeah. Yeah, so as part of the W3C spec, the question is accuracy information. As part of the W3C spec, you can request higher accuracy data, right? There's a flag in the options parameter that says whether you want high accuracy or not. The reason they put that in was because some devices have higher accuracy capability, like GPS. And the problem with that, though, is that GPS devices tend to use more battery power. So it was really more intended to let the user say, hey, do you want to consume more battery while getting your location or not? And yeah, you get higher accurate results, but the cost is more battery power. So yeah, it works on IE9. You can set that flag, and if the device has GPS, it'll try to use the GPS. Yeah. All right. So let's move on to designing mobile web forms. So mobile forms are an interesting subject on mobile because they're inherently constrained by the size of the screen and what the device can actually do, right? There's a bunch of things you can do that make mobile forms a little bit more usable. First, use top-of-line fields. Second, give the user the option to see password characters as they're being typed in. Third, prefer to use the built-in web form controls on the phone when possible, like select list or so on. The reason is because a lot of browser vendors actually build specific device-optimized things like select list for choosing information, so you should take advantage of those. HTML5 specifies new form input types, like things for like phone numbers and URLs and so on. You should start using those now, even if your device doesn't support HTML5, because older browsers won't recognize those and just fall back to using normal text input fields. So where you would normally say input type equals text anyway, just say input type equals, say, email. And if the browser on the device understands it, it'll customize the keyboard, the virtual keyboard, to show email inputs, right, with like @ and .com and so on. But if the browser doesn't understand it, it'll just fall back to being a regular text input field. So start using those now. So why do I say use top-of-line form fields? Well, typically what happens is something like this, right? You've got a form, and if you've got side-align fields, then when you put the focus in the form field, right, the UI zooms in, and then you're like, okay, what field was I typing in again? Dang it, right? So if you put the field names on top, right, you avoid that problem. So, and you can do this really simply with CSS, right? You can specify a CSS rule that says, hey, you know, if I've got a nice wide screen, then display the labels as block elements. Otherwise, display them as inline blocks. So what are the benefits, right? So A, they stay visible when you're zoomed in. You don't got to use fancy CSS to lay them out. It works with right to left or left to right text, but localization also becomes a lot easier, right? So if I translate that form into German and all the words triple in size, right, then the form fields are going to stay where they are, and the layout's not going to change. And again, they're optimized for vertical scrolling, right? They lend themselves well to scrolling vertically. All right, let's talk about passwords. A lot of times you'll see password entry. This is password entry on a normal form field. Some mobile browsers do this, but some mobile browsers are really helpful, right? They show you one character at a time as you're typing, right? You hit a character, and then it shows you the character, then you type. Right, yeah, thanks. I don't know about you, but you know, maybe it's just my personal opinion, but when you've got your phone, I'm typically using my phone like right here, right? I'm not usually showing the world my password. And the likelihood that there's somebody behind me, like, you know, trying to get my password, right, is not very high. So, I mean, why not just simply give the user the option of seeing the password as it's typed in, right? Just give a little checkbox and say, hey, do you want to see the characters? Yes. Right? Windows Phone does this throughout its UI. It's not a bad idea. Facebook actually does this, but they do it wrong. What happens is if you type in your password, they give you they give you number 2, and then if you enter it wrong, then the web page that comes back has just a regular plain text field in it, and there's this nice unreadable red box that says, hey, we're going to put your password in characters, so don't freak out when this happens, or something like that. I don't know, I never read it. But it's a lot better if you give the user the option of controlling it. So again, that way, if they're on a crowded bus, they have the choice. But as I mentioned earlier, HTML5 defines a whole bunch of new form fields, things like input types for URLs, emails, and you should use them right now because modern browsers will understand them, older browsers will simply fall back to text fields, and everybody's happy. So let's take a look at those. These are things right here, things like placeholder, autofocus. This is stuff that probably, I'm going to guess, just about everybody in this room has written JavaScript at one point or another to simulate this stuff, right? Placeholder text, right? The page loads, give this field the input focus. These are now just attributes in HTML5. So you can say things like placeholder equals this text, and then the browser just does that for you. So they're nice attributes. On browsers that recognize them, they work well. On browsers that don't, they just simply fall back to their default behavior. How am I doing on time? Doing OK? All right. Yeah, things like required fields. The nice thing about the HTML5 form fields is that on browsers that understand them, they'll also handle validation for you. So if you say like an input field is a number and the user types in something that's not a number, or they supply something that's not an email address, they'll catch that for you, or a URL, things like that. These are the new input types. There's it looks like a short list. There's actually more than this because when you get down to the second from the bottom, date actually comprises about 6 fields on its own. There's date and time, there's local date and time, there's week, there's month. So anyway, but these, if you use these in the input type equals box and the type equals attribute, that's how you specify. And again, the value here on the desktop is not necessarily so much other than validation. On mobile, it's important because mobile devices that have virtual keyboards will allow the keyboard to be customized for that input, right? So if you say type equals number, it'll show you the numeric keypad. If you say type equals URL, it'll show you the URL keypad. All right, so let's talk a little bit about IE9. So I'm going to begin by talking a little bit about how we approached building IE9 on Windows Phone 7. When we started off building IE9, there were 4 principles that we followed. One was, let's make sure that we enable HTML5 and interoperability of code via this principle of what we call the same markup. One of the things that we heard over and over from developers was we shouldn't have to write different markup to get our websites to work across different browsers. And we really took that message and said, let's make sure that in IE9, as much as we can, and as ambiguous as the specs can sometimes be, let's make sure that markup works across browsers because that's a big headache for a lot of developers. We also built it for performance. One of the main themes of IE9 on the desktop has been hardware accelerated HTML5, right? Everything that gets drawn to the screen goes to the GPU. So we're following the same principle on the phone. Basically, we're going to accelerate every single thing that we draw, and we're going to accelerate everything that we can through the engine. So we incorporated the new JavaScript engine from IE9. We're sharing the layout engine with them now. So it's a unified code base. If something renders on IE9 on the desktop, it should render on IE9 on the phone as well. The third thing we said was, what can we do to make a clean site-centric experience for sites on the phone? We wanted to reduce the browser Chrome as much as possible, let sites really shine through, let the site be the center actor on the stage. So I'll show you on the phone what we did. And then finally, how can we give people a safe and trusted browsing experience? How can we make it so that when people browse on their mobile phones, they don't have to worry about certain things that that are prevalent in the web today, like rogue controls or whatever. So that's what developers told us, and here's some details around what we did in response. So for interoperability and same markup, we implemented a ton of modern web standards. We went through the HTML5 specs. We went through a whole bunch of the stuff that's on the site. We implemented Canvas audio, video, XHTML support, a lot of the DOM support we put in, CSS3 stuff. For performance, I mentioned we did the same GPU acceleration that the guys on the desktop do, but we took a holistic view of performance. We said, how can we do things like, especially in the world of mobile, where you've got spotty data connections or things like network congestion. How can we give the user a more performant experience when sites are taking longer than normal to load, right? So we have a nice tiled rendering experience where, as the site is coming down, we detect where the user is scrolling in the page. We provide those tiles first, that kind of thing. And then for safe and trusted browsing, For clean sites, we reduced the UI surface area on. Who has a Windows Phone now? A few of you, yeah, a few. So on the browser that you have now, you'll notice that there's a status bar on the top, and on the bottom, that's where. So the URL bar is on the top, right, with a refresh button that doesn't quite look like a refresh button. And then on the bottom, we have that application bar with like the tabs and the favorites and so on. So we got rid of that. What we did was we collapsed it all down. And actually, why don't I just show it to you right now? It's easy enough to show. So what we did was we got rid of, there it is. And let me just bring it up. Yeah. So you can see down here the top, oh, look, it finally worked. So on the top, the status bar is gone. And down here, what we've done is we've collapsed the URL down into one bar on the bottom, a real, actual Metro-style refresh button, and then the app bar is now, this is where you get to things like tabs and favorites and so on. So the surface area available to the site is much larger, much cleaner than it was before. Let's focus is really out of the. Nah, I'll come back to it. Yeah.
You mentioned unifying the IE9 engine across.
Yes. Yes.
Is it still based on Shadok View?
Is it still based on Shadok View? We don't have the no. We actually we rewrote it from the ground up. We don't have the notion of doc host on IE9. Yeah. All right. Another thing that we did was we built our own web crawler, and we went out and looked across today's sites to try to understand what APIs are actually being used on the web today, and use that data to performance tune further our JavaScript engine. Does anybody know what the #1 JavaScript API on the web is today? Most common API? No, I mean API, like API function call. Good guess. Alerts. Anybody else want to take a guess? No? Yeah, but you know that though. Yes. So you would guess something like get element by ID, but it's actually index of. Get element by ID doesn't even crack the top 10, right? I mean, it's like number 13. But anyway, the reason for this, when you think about it, it makes sense. You know, a lot of JavaScript code today does a lot of string processing, right? So index of is probably used all over the dang place, probably in jQuery no less. So using data like this, we were able to say, oh, okay, what are people actually doing? Oh, people are using index of all over the place. Let's go make sure that our string processing is really nice and performance optimized. So for HTML5, I don't know how you guys probably don't know. I don't know if you guys know this or not, but HTML5, what the public has come to understand as HTML5 is kind of represented in this slide, right? There's like a whole bunch of specs, 50 plus, and they're in various stages of development. So the way that specs typically live at the W3C or the Watt working group, they start out in what's called an editor's draft, right? And then from there, they get worked on. They go into what's called the working draft mode, and then that wheel churns for a while, right? Those gerbils run. And then, assuming that the spec lives and gets worked out, it goes into what's called last call status, right? And then last call is when anybody can say, hey, if anybody feels this spec should not be implemented, please speak now, forever hold your peace. And then from there, it goes to candidate recommendation. Candidate recommendation means it's no longer killing small children out in the wild, right? We think it's actually stable enough to implement now. And then browsers actually get a chance to implement it. And then it goes to recommendation status where it's enshrined in the Hall of Fame. The jersey is retired, whatever. But what's the first thing you notice when you look at this chart? Huh? Exactly, yeah. Lots of orange, right? Lots of red, right? The stuff that's in the things that are in actual recommendation status are mostly the DOM stuff and ECMAScript. Candidate recommendation is pretty much SVG, right? Some of the CSS stuff, almost everything else, especially the entire HTML category, is all working draft, right? So what does this mean? Well, the way we approach this problem at Microsoft is that we understand that HTML5 is huge. So the approach that we're taking is let's avoid implementing specs that are a little bit premature, because when you do that, you can get locked into incompatible implementations, or you can introduce site-breaking changes, right? We saw this with WebSockets, for example. Like, Chrome implemented WebSockets in version 4, and then they had to change it in version 5 because the spec changed. So if you built a site that used WebSockets, you woke up one morning and your site was broken, right? And then they ended up disabling it because it was changing so fast and there were security issues. They just ended up taking it out of their mainline build. So we want to avoid a situation like that. And the way that we're approaching HTML5 basically is in the IE train, whether it's 9 or 10 or whatever, we're going to provide implementations for specs that are stable and what we call site ready. Not necessarily candidate recommendation, right? Things that are stable, things that are widely implemented, things that are not changing much, we'll implement those. But then we're going to do these things called platform previews on the desktop, and we're looking at ways that we can do this on the phone. We don't know how we're going to do this just yet, but the idea is let's give you guys platform previews that developers can then use to get their sites ready, right, without having to worry about their customers waking up one morning and going, oh, that's broken now. And then the last thing that we're doing is for stuff that's really experimental, we have a website called HTML5 Labs. And if you go to HTML5 Labs, we provide implementations there for things like WebSockets, right? Things like IndexedDB, stuff that's really not stable. But the idea is you download a plugin, you install it as a developer, you work and work and work, and then we follow along with implementation changes, so that way your code is isolated and your customers aren't worrying about it. So that's how we're approaching HTML5. Partial summary of stuff that's in IE9. I'm not going to go through all this, but this is a pretty good summary of the stuff that we built into IE9 Mobile. We implemented stuff like SVG, a lot of the HTML graphics stuff, a lot of CSS stuff. If you've had a chance to play with IE10 Platform Preview, you'll get a sense of where IE10 on mobile is going to go, because now that we have the same rendering engine, right, we'll just simply fall in lockstep with those guys, so whatever they implement, we'll eventually pick up. We also did some things like we implemented the, support for data URIs. Anybody not know what a data URI is? Right. Yeah, data URIs are basically just a way of embedding what would ordinarily be binary data into a web page, and so for like small icons or things like that, to reduce HTTP requests. And in IE8 and before, you could do that in images, but only up to 32K. We removed that limit. You can now have data URIs up to 4 gigs, and you can use them in images or JavaScript source attributes. Anywhere you can put like a source attribute, you can now use data URIs. I kind of already went over the key IE9 mobile features. I talked about stuff like support for viewport, geolocation, media queries, the data URIs. We also implemented things like DOM local storage. So if DOM local storage is present on a device, that's usually the preferable way of storing data rather than using cookies. The problem with cookies is that cookies are sent to the server on every request, so they do a complete round trip, so it bloats the request stream, number one. Number two, unless your site is entirely SSL, cookies are sent as open text. There's clear text across the wire. So security-wise, they're not necessarily the best thing for storing, information that you want to be stored on the client. That's what DOM local storage is for. So if it's present, it's better to use that. Let's see, I got about 7 minutes left. So the last thing I want to talk about is, in addition to all the IE9 stuff that we're doing on mobile, we also have an embedded browser control that if you're building native apps, you can use. So it uses the same rendering engine as IE9 on the phone. If you've already used it on apps you've built for Windows Phone 7, it'll just automatically update to use the IE9 rendering engine. If you don't include things like a doc type, it'll automatically fall back to the 7 Quirks rendering mode. But if you put in a doc type, it'll use the right standards rendering mode. All right. We've got to the point now where we're at the end of the session. This is some related content. All this stuff is in my slides. The last thing I really want to do is I'll just spend a few more minutes showing you just some demos on the phone. And I want to just go ahead and skip ahead to the win the phone contest. Actually, no, I want to skip to there it is. So we're making use of QR code tag readers this year for evaluations. I think the idea is that if you have a phone, just go ahead and scan that thing right up there on the screen, and you can fill out your eval. But I'll put that back up. I just want to show you guys a couple of quick demos of stuff that we've implemented on the phone. So let's see. We've already seen. Where is it? There it is. Yeah. Should I try to keep the light off, or there we go. So we've already seen geolocation. Let's take a look at. I don't know if you guys have seen this one. This one is what's called a speed reading demo. Each one of those little letters that you see being rendered on the screen is an individual canvas that we're using our graphics acceleration to draw to the screen on. You can't really make it out probably from the screen there, but we're getting a frames per second rate of about 27. if you saw the same demo done at Mix, we put this up against an iPhone 4, and it was getting around 2 frames per second, and I think the Android was getting around 11. So hardware acceleration, clearly makes a difference. You can the video's available online, and these are also available online if you go to the IE test drive. Let me show you another one really quick. So this is support for SVG. When this thing loads up really quick, we'll take a look at this. So this is a chart. That chart there is done. Wow, this projector is really kind of hairy. So what I'm going to do is just click on the data series from 2011. You can see that the chart animating back and forth. This is just support for SVG on the phone. Let me show you quickly also another one. This is, whoops. Let me go back to the favorites, and I'll show you this one here. This is that IE logo you see right there is being built using divs with CSS3 border radius. So if I just click the animate button, you can see all the divs just kind of animate into place. So each one of those blue swooshes is a div. That big orange swoosh is a div as well. So anyway, the idea here is that we've added a lot of support. It really is IE9. It really is on the phone. I'll be walking around the show if you guys want to see it. I'll be at the Windows Phone booth as well. In the meantime, I've left